In this video, we're going to talk about formulas and the types of questions we're going to see in Math 92 relating to them. So I'm just going to start us off with an example. So when we're talking about geometry, that's a place where we see a lot of formulas. So one of our favorite geometric figures, the rectangle, right, has the following formula associated with it. Our perimeter is 2 times the length plus 2 times the width. So you have 2 different lengths, 2 different widths, and you add them all together. So that's our formula. We know that there are 2 ways that we need to use this formula in this class. One is just to use the formula. So if we had a rectangle and we happen to know it was 7 by, say, 13, well, we could use this formula to figure out what the perimeter was. We could go ahead and plug in 2 times my length, which is 13, plus 2 times my width of 7. So 26 plus 14 is equal to 40. Right, so that's one way we could use these formulas. There are also a lot of times, and we saw this in the Down to Business worksheet, where if we're doing this a number of times and we're solving some other way, so let's say for our formula, again, we'll use still the rectangle. Let's say now we know one side has a side length of 15, and we know that the perimeter is, let's say, I don't know, 46. So if we're looking for the other side length, well, we could still use the formula, right? We still have, for this formula, we have 2 parts of it, right? We have the length, we have the perimeter. The only thing we're missing is W. We have all the pieces except for the one we're missing. And so we can go ahead and plug in, put in our perimeter of 46, our length of 15, and leave the rest of it the same. Oh yeah, and this is our W. And then we could work with this, right? We could do all the math that we're used to doing. 2 times 15 is 30. It's equal to 46 plus 2W. We could solve for that W on its own. Right? That's all stuff we could do. We could keep going forever and ever and figure out that W is equal to 8. Now, if we were doing this again and again and again, it would seem silly to do all of this work every time. What might make more sense is to do something we're definitely going to see on the exam on Monday, and that is solve for a particular variable. So let's look at our equation again, and then we're going to go ahead and look at this problem one more time. So if we know that we want to find the width, given a perimeter and a length, it may make more sense to solve for the W. So we can just figure out what W is, no matter what perimeter and length are thrown at us. So in order to do this, we're going to still follow our basic principles for solving equations. So we want to get W alone. That's the goal. Now, we should take a moment and look at our formula and see what's going on inside the formula. What's happening to W? We can see here when we break this down, W has a 2 multiplied to it, and it also is being added to 2L. So we have these 2 different things that we need to get rid of or undo in order to get W by itself. So the first step would be, let's get rid of this 2L. We could divide by the 2 now, and I'll actually do that on the other side as well. But this would be the first step if we're thinking general ways. Usually we get rid of, we do the addition or subtraction principle before we do multiplication or division. So now we would be 2p minus 2l is equal to 2w. We're still looking to get w by itself. And the only thing that's happening in w still is this multiplication, which we can undo with a division. So we end up with our final answer that w is equal to p minus 2l all over 2. Now, I will tell you a mistake a lot of students make is to divide or to cancel this 2 out and tell me that the answer is just P minus L. I'm going to talk about why this is wrong in a second. Don't do this. Don't. And the easiest way to do that is to show you if we had started by doing the division first, because that is allowed. It's just not generally how we do this question. So here's the other option. So still looking for W, but this time we go, screw this, let's get rid of the 2. Now we need to do this to the entire side over here. So zoop, the entire thing is divided by 2, and we need to be fair, so it needs to happen on both sides. So this is what we're looking at. Now, the left side is easy. We just have P divided by 2. The right side is not as easy. Really, when you divide something, if you have 4 plus 6 over 2, right, you're actually dividing both the 4 and the 6 by 2. Right? This would have been 10 over 2, which is 5. So you need to divide both pieces. You can't just divide the front half. You can't just divide the back half. That's not allowed. Both terms on that side have to get divided by 2. So that's what needs to happen on the other side. And that's something you can do. What I just did there on the bottom is how I usually check to see if what I'm doing is allowed. I just make it a simpler question, change it to easy numbers I can work with. And now, one more step, we got to get that W alone still. Let's subtract the L. So this version's answer looks like this. W is equal to P divided by 2 minus L. Different looking than this one, but it's definitely not P minus L. So what I just said in the last one about needing to divide both sides, or both terms on a side by 2, yes, it divides into this, but it doesn't divide evenly into P. So you have 2 options in terms of writing your answer. You can divide both sides by 2, leaving P over 2 on the left, or both terms, or you can do this. Okay, I said I was going to show you how this worked with the last question. So let's look back at that example. So remember in our example, we knew we had a side length of 17, and our perimeter, I think it was 46. So now if we know that the length is 17 and the perimeter is 46, this new formula that we have, whichever one you want to use, lets us immediately get out the width. So our width is equal to 46 over 2 minus the length, which is 23 minus 17, which is 6. Either I screwed up the last one or I used the wrong numbers. Oh, I used 17 instead of 15. Oops, let me redo that. So 15. So if we did that minus 15 instead, this would be 8, just like we got in the last question. Probably should have written that down. But either one of these is going to pop out that width that we found the other way without us having to do extra algebra. So the question is, usually for these types of things, it's easier to do the algebra with numbers than it is to do it with letters. But if we were doing a lot of calculations, it would be easier. It would make more sense to do this algebra here up front so that we weren't doing the same algebra over and over and over again. So I'm going to do one more example, maybe. We'll see. Our example here. Let me see. I want to find something not geometry related. See if I can find something from science. So I'm trying to grab one. This book is useless. Hold on 1 second. All right, this was the best I could come up with. Solve S is equal to A, parentheses X minus V, times T, and the parentheses for T. So I want you guys to take a moment, try pausing the video, see if you could solve this thing for T on your own. All right, so coming back, T is the thing we want to get alone. And again, hopefully you took a little bit of time to think about what's happening to T. So first thing that's happening to T, or the most inside thing, is being multiplied by V. That is all being subtracted from X. And then lastly, all that whole quantity is being multiplied by A. Solving an equation is sometimes like peeling an onion. We kind of want to deal with the most outside thing. What's the last thing that happens to everything first? And you have other options. So this is just how I see it. I know this is how Oscar would do it. I'm going to go ahead and divide this by A. Because then this A and this A cancel. And this is allowed to do this canceling. It's not like the one before because the A is being multiplied to everything. So dividing something that we're multiplying by undoes it. We didn't have that ability to do that, because when we were dividing something, we were subtracting or adding. That's not undoing, right? It's applying to both pieces. So this is one way we could do this. Is go, okay, let me cancel those a's. That's going to leave me with s divided by a is equal to x minus vt. And now we're at a point that looks pretty similar to the question we were doing before. T is by itself over here. We could divide by v, but it's going to make things really messy. So let's first subtract off that x that's being added to it, right? It's a positive x. We got to subtract to get rid of it. Leaves us with s divided by a minus x is equal to negative vt. Holy crap, I almost forgot that negative. And then our last step, divide everything through by negative v. Ugh, gross. So t is equal to s over a minus x, all divided by negative v. This is ugly. And this is my own fault for trying to be clever and doing that instead of distributing first. So let's just redo this with the distribution. See the difference. Oops, I don't need that yet. S is equal to a x minus vt. Cool. If we distribute it first, we're actually going to be better off for this one in terms of having something pretty to work with and actually giving ourselves a little less steps. So we get s is equal to ax minus avt. And then we say, okay, we still want to get t alone. It's very similar to what we were doing before. Minus ax minus ax. S minus ax is equal to negative avt. And then we divide by the negative AV. So we get a slightly prettier version of this. So that's probably the version that makes more sense to us. It's way less confusing than that, and kind of follows more what we're thinking in the first place. But both are legitimate. This is correct, although it is hideous. And most math people, having a fraction inside of a fraction is a big no-no. We call it a complex fraction. So this could be cleaned up to make it look like that and pretty again. We'll talk about how to clean that up in a later chapter, way later in the course. So hopefully that makes a little bit of sense. I'll give you one last one as a closing. If you want, you do not need to keep watching if you feel like you get it. But 4x plus 2y is equal to 8. Let's solve this for x. Now remember this one, the problem here, the mistake that's going to happen a lot, is that students are going to do what you guys suggested on the JITT and set something equal to 0. That's finding an intercept. We don't want to do that. We are trying to just get x alone. Remember, in these formula questions, we're trying to just make a new formula. The goal is to just get x is equal to, and then have a whole new giant ugly formula on the other side. So we'll still have y's in our answer. So first thing we want to do, get x alone. We can see it's being multiplied to 4, and then this thing is being added to it. Let's get rid of the thing that's being added to it. And then if we want to get x alone, divide by 4, divide by 4. Remember here that division, because this is the mistake that's going to happen on a lot of tests, happens to each piece. So you can make this like that if you want to, or you could actually simplify that down. Something like that. There are a lot of different options for your right answer. I am not worried on the exam about you simplifying. So when you get here, feel free to just say x is equal to negative 2y plus 8 over 4. You have a completely and utterly functional thing to do. No one said simplify it as much as you can, so leave it in the first time that you get to the right answer, because otherwise you're going to do something silly like come through and try to say, oh, those cancel. This is negative 2y plus 2, which is not true. So don't go too far. Stop when you get to a place when you feel comfortable. If you want to show off and go further, feel free. But know that it's at your own risk, because I will not dock you here. But if you get here, doesn't matter if you had the right answer up there, I have to take points from you if you make a mistake.